So if x squared minus 3xy is 12 and dx by dt is 6, then determine dy by dt when x is 3. So what we want to do is take the derivative with respect to time, with respect to t, of both sides, right? So we're just going to take the derivative of x cubed with respect to t, which is 3x squared times dx by dt. And then we've got the minus 3xy, which is a product, right? We could pull the 3 out if we like, so we could just go minus 3 times, and we're going to worry now about the derivative of xy. Okay, so it's going to be x times dy by dt, right? So it's fg prime. You can actually do these in any order, but then it messes me up when I go to look at it and mark it. So this is over there, and this is over there. Plus, and then we've got y times dx by dt. Equals, and the derivative of 12, 0. Okay, so we got a 3 there and a 3 there, and we got a 0 over there. So I could divide everything by 3 to just get x squared dx by dt. Forget the 3, but let's distribute the minus. So it's going to be minus x dy by dt plus y dx by dt equals 0.
If you're distributing the negative, it has to be minus.
Right, it does. You tied in. The deliberate ones are when I write a minus, and it should be a plus, because then you don't have to erase it. Right. The not so deliberate ones. Okay, so what we want to know, so when x equals 3, okay, so we know that dx by dt is 6, so we got this. And we know that when x is equal to 3, so we got this and we got this, and we want to find dy by dt, which means we need y. So we just have to go to the original, right? Say, well, when x is equal to 3, so when x equals 3, then we've got x cubed, so 3 cubed minus 3 times y is equal to 12. Okay, so we're just going to get the value for y, and then we'll have everything we need, right? Except for the one thing we're trying to find. We'll fill it in and solve. Okay, what do we got? 27 minus 9y is 12. Negative 9y is negative 15. Negative 15. So y is 15 over 9. 5/3. Yeah. Say negative 15 over negative 9 and then get 5/3. Okay, so we've got y is 5/3. And now we could do a couple of things. We could just throw it in, or we can solve this for dy by dt first, like in a more general sense. Just solve for it and then substitute in. So I kind of sometimes like the idea of just solving for dy by. So let's just move this over there. So it'll become x dy by dt is equal to, we kind of reverse sides. So we got x squared dx by dt minus y dx by dt. So dy by dt, we're going to divide through by x. So this will be x dx by dt minus y over x dx by dt. And if we like, we could factor out, but we don't have to. So at this point, we can just substitute in. So we're trying to find dy by dt. Okay, and what do we know? So we know when x is equal to 3, and dx by dt is 6. And we've got, what was that, 5/3? We're dividing by x, so let's multiply by 1/3. And dx by dt is 6. So we get 18 minus 10 thirds. Uh, 54 thirds minus 10 thirds, so 44 thirds. I'll just go across. So 54 thirds minus 10 thirds. Okay, so I just go to, so dy by dt is 44 over 3. Okay, and that's what we wanted. Okay. Last one of this. At 1 p.m., boat A is 25 kilometers due north of boat B. If boat A is sailing west at a rate of 16 kilometers an hour and boat B is sailing south at 20 kilometers an hour, determine the rate at which the distance between the two ships is changing at 1:30 p.m. or basically after half an hour, right? So that's what we have to take into account. So boat A is 20, so let's put A here. Let's put B here and say this distance, which is not a straight line, this distance is 25 kilometers. Okay, and now A is sailing west at a rate of 16 kilometers per hour, and B is sailing south, so that's where it started, and now it's going this way at 20 kilometers per hour. So, let's say 16 kilometers per hour. 20 kilometers per hour, and there's a certain distance between them. So, and this is be the distance between the two ships. Okay. Right angle triangle there because we got west and we got south. And we've got boat A, so let's say we're going to call it dA by dt. The rate at which boat A is moving is 16 kilometers per hour. And then we've got boat B, so let's say dB by dt is 20 kilometers per hour. And we've got a relationship between these guys. So we'll call this distance here little a, and we'll call this distance here little b, right? And that'll be just this. So we've got a right angle triangle with a, 25 plus b, and then let's call that z. So we know that z squared will be a squared plus 25 plus b quantity squared. Whoops. Now, what we can do with that really is just different. And what are we looking for? We're looking for dz by dt, right? We're looking at what is the rate of change of the distance between the two ships, which is z. So if we just take the derivative of both sides with respect to time, then that z squared just becomes 2z, right? So it's going to be 2z dz by dt, right? And then we're going to have to figure out what z is, but we know that it's after half an hour, right? So we'll be able to figure out those distances. So let's just differentiate this with respect to time. So 2z dz by dt is equal to 2a dA by dt, okay, which we know, right, because we can fill that in. And then we've got the b there, right? So we've got 25 plus b squared, so that's going to be plus 2 times 25 plus b times 1, right? Don't forget the 1. You don't need the 1. Times dB by dt. All right, so divide everything by 2z, right? So we'll isolate the dz by dt. So dz by dt is going to be, so 2a divided by 2z is going to be a over z, dA by dt, plus, okay, 2 divided by 2z will be 1 over z times 25 plus b times b dB by dt. All right, so what do we know? dA by dt, we know dB by dt. We are going to figure out what's A, right, at a half an hour, right? So in half an hour, how far did this go? So at 1:30, at 13:30, little a is equal to 8, right? So 16 kilometers an hour, but in half an hour, you've got 8 kilometers. This distance here is, or little b, what's little b? So b is, you're going 20 kilometers an hour for half an hour, you went,
10 plus.
so little b is 10 kilometers, right? And then, because what we'll do is we'll just use that because we've got this expression here, right? We're going to plug into that. So we'll just put the little b. It'll be a 35, right? We know that this distance will be 8 and this distance will be 35. Okay, so z is equal to, we want z, it's going to be the square root of a squared plus b plus 25 squared. So 8 squared plus 35, right? Just write 35. So we got 64 plus, right, square numbers ending in 5? Yeah. So if you want to square a number ending in 5, it's going to end in 25. And then you take the number in front of the 5 and multiply it by the next higher number. So 35 squared is 3 times 4 is 12, 25. 55 squared is 5 times 6 is 30, 25. Math trick of the day. So 1225, which will be the root of 1289. Okay. Now, I mean, we're just going to leave it as root 1289, right? I'm not going to try and do anything fancy with it, right? And that just means our answer, you know, if you want a number, then we plug it into a calculator to get a number, right? And on a test, we'd either give you easier numbers so that it actually had a nice, you know, like 3, 4, 5 kind of stuff. And that. All right, so what do we got? dz by dt is A was 8 over the root of 1289 times dA by dt, which is 16, plus 1 over the root of 1289. Suppose I could have factored 1 over z out of that if I wanted. Times 10 plus 25 times 20. And, I don't know, 8 times 16 is 80 and 48, so it's going to be like 128. 35 times 20 is like 700. So 828. This is about 23.06 kilometers per hour. Okay, so we give you a nice, or just ask you to leave it in that form, right? You don't need to be doing too much arithmetic. So if the book gives an answer, you might have to get our calculator just to work out, you know, say, oh, yeah, okay, that problem is long. All right, so that's related grades, 1 through 11. Note the answer in book number 50 apparently is horizontally 20 kilometers. It's just a correction that's on your sheet here. Okay, tomorrow, trig-related rates, so 4 examples of that. Work max-min problems Friday and Monday. Okay, and away we go, just through the rest of the timeline.